I'm going to start with a story. I heard that was a good idea. Right when I got into software development, right out of college, I joined a web consultancy, and this is like 2004. And we were, what I felt was cutting edge. We were using Dreamweaver, and we had things mounted on like a shared server, and you know, we had passwords, and it was cool. And whenever you needed, you know, access to things, you could really just go to the code. And we decided that didn't scale well, going into all these projects, trying to check them out and stuff. So we came up with this idea of we're going to have this file called passwords.txt, and that's where it's going to be, right? And so, you know, that scaled as well as you can imagine it would. And eventually, you know, it was time to move on. And I told myself, I can't wait to go to an organization where we don't have that, right? We're going to be cutting edge. And so I joined this Rails organization. I moved on, and I was like, man, we use Rackspace here, and we have Git. Not only we have Git, we had Subversion at the last place, the person before that. Nothing wrong with that. We had PHP too, and there's nothing wrong with that, and I will discuss that with any of you if you want to later. And so I go to this new place, and I'm like, yeah, Rackspace, and we're looking at using like Chef to do this stuff. Like, these are cool things I've heard of. I can't wait to be using them. And I get there, and it's like my first week, and I'm like, all right, I want to do some stuff. How do I get access? And they're like, yeah, here, we'll show you how to get access. You got to go to our shared drive, and there's a passwords.txt file. So, my name's Clint Shryak. I'm a Vault engineer at HashiCorp. And I'm proud to say I don't use password.txt anymore. You know, you can find me anytime in this conference if you want to talk about how you still use password.txt. It's totally fine. We can help you with that. So today I'm going to talk about breaking the ice, secure introduction with Vault and Kubernetes. I chose breaking the ice because I was going to a tech conference, and I find that's something that I struggle with at conferences. I see a bunch of random people who, in theory, have similar interests, but I still don't know how to make conversations. And that's kind of daunting to me. Just like if you're using a large platform like Kubernetes, how do you integrate with a new thing? Vault's non-trivial. So how do you get across that threshold? Turns out integration's not actually that hard, but you have to start somewhere. And starting can be very hard. So today we're going to look at some integration things. We're going to cover these things very quickly. I really hope I updated this slide correctly throughout the whole presentation. So, what is Vault? Why you should use it? We're going to talk about that because I don't know how many of you come to this room with Vault experience or knowledge. Who would say they know Kubernetes better than they know Vault here? All right, I'm going to pretend that's more hands than the other way around of I know more Vault than Kubernetes. Who knows more Vault than Kubernetes? Well, I'm going to go with my first thing of more Kubernetes than Vault. So, we're going to talk about that. We're going to talk about actually integrating, which is a very fancy word for using Kubernetes to authenticate. And we'll talk briefly about using Vault as a service inside Kubernetes, which was something kind of announced newish that we support now. And in the end, I'm going to talk about secret injection, which is another kind of vague, nebulous topic. But we'll get to that. So, hold on. I gotta make sure I know. Okay, yeah, so we're talking about Vault. If you know anything about video games, you maybe have heard of a speed run. So I'm gonna give you a speed run of Vault, assuming you know more Kubernetes. All that means is we're gonna show you some really quick things about Vault, just to kind of get you the idea of what it is and what it can do. So Vault itself is highly available. It is a distributed application. It has a leader-follower pattern, very similar with our other products, Nomad and Consul. Externally, you communicate with Vault over an HTTPS API. You don't need a special SDK or something. It's all HTTP. Internally, it's very similar to Consul and Nomad in that we use RPC to separate a set of core functionality from extendable backends, as we call them. Core and plug backends. Backends generally fall into two categories. They are auth backends or auth methods. Kind of use that interchangeably, and secret backends. Auth methods are for proving your identity, and secret backends are where we do the fun stuff. I thought I had a good way to explain that, but so anyway, identity can be humans or machines, right? So you can use Vault with GitHub, and you can authenticate with Vault using your GitHub credentials or logging into GitHub or LDAP. For machines, you could use IAM profiles or, in italics, service account tokens, because that's what we're doing today. When you authenticate, you log into Vault and you log in for a specific role, and these roles are tied to the secret backends that you're trying to use. Or the authentication backend roles that you're trying to use. And those roles they have policies attached to them. These policies dictate whether you can do certain things. Can you interact with this backend? Can you talk to this? Can you operate Vault itself? So Vault is identity and policy driven. Okay. All right. So some of the secret backends, this is a very, very small list, but Vault itself can act as encryption as a service. So you can ask Vault to encrypt a certain thing, and it'll return that to you. In that case, we don't actually store it. We just have the keys that maintain the means of encrypting and decrypting. You can also do things like manage your PKI infrastructure, generate certificates for servers to talk to each other. You could probably use that for actually using or creating certificates in Kubernetes. And then this other thing, which I feel like I spend a lot of time discussing, is this concept of dynamic secrets. And dynamic secrets are just like my slides. They're created just in time, right before you need them. So the idea of a dynamic secret is, it's like my passwords.txt file, except nothing like that, and dynamically created the moment I need to access a database. I say, Vault, I need to talk to this database. Vault says, okay, here's your username and here's your password. And like most things in Vault, most secrets in Vault, it has what's called a lease. It exists for a certain amount of time. And it's configurable by backend. But let's say it exists for an hour. In an hour, Vault will automatically revoke that database username and password. Unless, of course, I go and try to renew it. I tell, hey, I'm still using it, but I have to check in. So the advantage there is you can give people secrets and access to things and know that they're not going to end up in a passwords.txt file. And even if they did, it wouldn't matter because Vault automatically expired them. Now, let's say someone is malicious and they do a password.txt file and they keep renewing it and you discover it. Because we have this concept of leases, an administrator can go and revoke that lease manually. So dynamic secrets are meant to be short-lived. They can live longer. And they're supposed to be kind of per use scenarios. So I'll cover that in a little bit. All right, what's next? Okay. See, I told you it was a speed run. So in review, right? Vault, highly available. We have a leader-follower setup. All requests to followers actually get sent to the leader. So the followers don't necessarily really do anything. They are hot standbys. The exceptions there being our enterprise version of Vault has performance nodes and some other things like that. Those are enterprise features, and I'm focusing mostly on open source today. So everything you put into Vault is securely stored by default. We use a system of encryption keys. It's another topic called Shamir keys to generate a master key, which then stores everything in your configured backend securely and encrypted. We have a lot of different backends, and that'll be covered a little bit later. Identity, role, and policy driven. Your identity is scoped to certain permissions, and by default, you have no permissions. You have to explicitly have policies added that give you things. So the idea is to promote secure by default, meaning you can't do anything. And then we have managed secrets, dynamically generated as they're needed, and if ignored, they get cleaned up later. All right, so really quick, what is Vault and why should you use it? It's amazing, and it does great things. So that's a quick speed run. Let's go to the next thing. Integrating Kubernetes with Vault. Okay, checking my time. I have no idea how long my demo is going to take, so we'll see. All right, so we already knew that Kubernetes is great. That's why you're here. And you had an idea that Vault was great also, which is why you're here. So we're going to talk about integrating Vault and Kubernetes. We're going to get these two systems to talk. We're going to want a Kubernetes application that's going to get dynamic secrets for a database. We'll use that as an example, right? So we have an app. And we can clearly see that this app is written in Golang. And this application needs a database. So here we have a database. And this database is clearly PostgreSQL. I'm not trying to make anyone mad. So I don't want to run any of these things myself because I'm not necessarily an infrastructure person myself, and I don't like babysitting applications and databases. So we're going to put these things in a service scheduler, which is clearly Kubernetes, because it says so. And I don't want a passwords.txt file involved. So we're going to make our application get its information from Vault. That's clearly Vault. It says so. And that dotted line there is meant to represent kind of a problem we have. That's commonly referred to as the secure introduction problem. How does Vault know that this app, this machine, should be entitled to a secret? How do we provide that very first step? How do we get the very first secret established, that level of trust established, right? So to do this, as a human, we have a lot of different ways, but we use authentication backends to basically ask somebody else to verify this identity. So in the example earlier, I said GitHub, right? They set up GitHub authentication in Vault, and then we actually get redirected to GitHub, and you have to log in there, and GitHub says if it was actually successful or not. For machines, you have things like IAM, or you have service account tokens. So what we end up doing here is we leverage the platforms themselves that we're running these things on to establish trust, right? This is a fancy image that I got off of our website. And it's pretty much just kind of reiterates what I say. Basically, you use a secure, supplied, unique token that an application has access to pass that to Vault. Vault then asks this identity provider, is this legitimate? And that all maps down to the role that the person tried to log in as. And then when the platform verifies it, we say, OK, I can now issue you a Vault token, which is a secret itself. It's just a string. And says, here, you can use this now as your means of authenticating with me. You get this nice Vault token, and all your requests after that, you say, hey, here's my Vault token, give me this secret. The Vault token itself has those policies bound to it. So when you use the token and say, I am this person, Vault will then check the policies on that token and say, do you have access to the secrets you're asking for or not? So really integrating between Kubernetes and Vault is actually really simple there. We just need the service account token from your pod. And super hand-wavy magic, we're authenticated and we are configured to give you certain policies and certain secrets. Sorry, I'm trying to figure out where I am. OK, so this is obviously very, very complex, but we show that Kubernetes and Vault here need to talk. So let's look at the workflow again, really quick, right? We're going to use the service account token to authenticate with Vault. We're going to receive token that we can then turn around and ask Vault again to actually do the secret things that we want to do. There's actually a couple hoops to jump through here, right? But those secret things we can do are, as I mentioned earlier, encryption as a service. We can encrypt things for our users, and we don't actually store them. We can give them the encrypted value, but we hold the keys to unencrypt them. You can restore access sensitive information, maybe URLs. Maybe you went ahead and just did a static username and password in a key value store, or you can do dynamic credentials. So in Kubernetes, we obviously have a lot of these things running, right? We have many of them. They're in a 12-factor style application where they don't have a lot of information themselves. They have to get the information from their environment. And in this case, we're going to use the service account token to kick all that off. So to get the actual integration going, we need to set up Kubernetes to have the things that we need to have. And that starts by simply creating a service account, right? This is a service account, and it needs to have special permissions. This is a service account that Vault is going to use itself, not one that your pods are going to use. So I don't know. Hopefully that's readable, but it's on our website. It's very generic. This is a role-based access control definition that just says this service account I'm creating has access to the token review API. What we're going to do is to configure the Kubernetes authentication backend, we need to have a token that we can use to communicate with Kubernetes and say, hey, this other token I've got, is it valid or not? What is its real identity? And so we need a token that has the capabilities to do that. And then we also need this other thing. We're just going to use this for our web server or our apps. And that's going to be the service account token that's associated with your pods that you run this application for. So that's all you really have to do on the Kubernetes side. On the Vault side, I mentioned policies and identities. We have to create a policy. Really simple policy here. Policies can be things like listing values, reading values, creating values, deleting values. And we have what some people I think is very jarring at first, this concept of dynamic credentials being read and not necessarily created. Reading is actually the way you create them. It was kind of odd to me at first, but they don't exist until you read them. Sounds like creation, but we'll get on that. So everything in Vault is path-based. So we see here the path is database creds awesomedb. That doesn't exist yet, but when it's a policy, that doesn't have to exist. You can write a policy like this. And everyone loves to write policies. So we will get to, actually I think I skip over that part. Okay, so we write that HCL file, we store that to Vault. Sorry, I skipped the part where we use HCL to define our policies. If you're not familiar with HCL, I'm afraid I don't have an introduction for it, but it's kind of like JSON, but, well, I'm not supposed to say more than that. I have no problem with JSON. There are some people who are not big fans of YAML, though. Okay, so this is a policy, and we are going to set up Kubernetes authentication in Vault. We're going to enable the backend. Vault has a lot of stuff built in, but as I mentioned earlier, we try to be secure by default, so we have very little turned on to begin with. I think Vault gets turned on with KV and token, and maybe user pass. I don't know. Basically nothing. So we're going to enable Kubernetes. We're going to say, hey, we want to talk to Kubernetes. So internally, it already ships with this binary, it already ships with this backend. Vault will then kind of mount it to a path. You can provide a path, but it overflowed the screen, so I removed the path. If you don't provide a path, it takes the default name. In a more production environment, you probably don't want to use the same name or just Kubernetes. You want to give it a nice name like demo or production. It'll just save you trouble later. All right, I also skipped over the Vault auth jot there. JWT, I pronounce it jot. I got one thumb up, that's enough for me. All right, so I skipped over how you get that, but you need to use the kubectl to get there. You need to access, every service account has a secret name, and you can access the secret name by asking kubectl about the, sorry, that distracted me for a moment. About the service account, and then from there, you can get the token, right? So we need to have access to that. This must be set up by an administrator who had those things. We need to know the host, which, yeah, generic host. And we need to have access to a CA cert file, a certificate file that Kubernetes is using. We use that to establish the connection with the Kubernetes API and do this in a secure way. And so we store then the Vault token. So we're going to use that for future API access. All right. Next thing we'll do is using, again, the path, auth, that denotes the backend we're talking about. Oh, I forgot to edit that one. That was the custom path, Kubernetes demo. I forgot to edit that slide. Role web. In this screen, we're creating a role. We're saying there exists a role that someone can log into, and we are binding it to the web server service account name. And we'll say the default namespace. You should ideally probably narrow this down as specifically as possible. But when someone logs in with a token for the role web, we need to make sure that the service account token is the web server token and it is in the default namespace. And if all that's successful, I'm going to return to them a token that has the awesomedb policies. And this token, I'm being generous, this token lives for 25 hours. By default. After 25 hours, you can continue to use the token, but it'll just fail. We'll just say no. Those tokens, like any token, are renewable, but you can configure that to maybe not be renewable. All right, so the idea then is we are going to run a web server, and we're going to associate the service account with each one. So back in Kubernetes, that's what we're doing here. We're going to run this app, and because we love demos that fit on screens, we're not using a deployment file. We're just doing it right away. And then, okay, so we say the service account. The image is our awesome app image. And then we go in there manually, just for demonstration purposes, and then we can get the Kubernetes token, right? That's the default service account token. And then we can actually curl out, because everyone loves curl, to Vault. And we can say, here's our kube token. We want the web server role. And Vault gives us back this. It's a lot of neat information. It should give, okay, that lease duration probably doesn't match up with the TTL, but don't worry about that kind of detail. Worry about that client token detail. That is then your authentication token that you can then turn around and ask Vault for secrets, and your requests will be checked against the policies of that token. In this case, the policies are, I want to talk to the awesome DB, and I want credentials for it. So when I ask Vault, I say, hey, give me these dynamic credentials. It returns me credentials that did not exist until the moment I asked for them. And these credentials are bound by the way we configured the database to expire at a certain amount of time. And the way you can configure the database, again, I left that as an exercise later. You get custom SQL creations things. So you could say that this role only has access to certain tables. This is a read-only role. Those are all configured by the database backend. And so you get credentials that now give you access to this. OK, so I did go over that really, really fast. But I tried to kind of be general in it. It's not very complicated, the workflow. But it is arguably non-trivial. It's hoops you have to jump through, right? So by hoops, we review, right? Read the service account token. Ask Vault to log in. Ask Vault again for the actual secrets you need. And then you can finally go about doing what you came to do in the first place, right? Or the application would go and do and finally get to do these things. It's more steps. You have to add code to your applications. I don't know about you, I'm this kind of software developer who would rather not maintain code at all. You know, that's like the best code, right? But now we've asked you to add more code. And in the name of security and integration, you now have to add code. So that's a really simple integration. That's a really easy way to start talking to Kubernetes, right? And from there on, it's just API calls. But we want to make this easier for you, right? So we look at these things, and we know we're authenticating with a platform. We know these things are there. We need to just do some of these things for you. So if you're unfamiliar with it, we have a feature in Vault called Vault Agent. And it's Vault itself. It's the same binary, but you run it in a specific mode. In that mode, it operates just like a daemon, and you configure it, not like you would configure Vault with backend storage and stuff. You configure it just as another Vault client. And you say, here's my Vault, here's my authentication method, and here is where I want my token to go, right? So when you run Vault Agent, in this context of Kubernetes, it knows where to go for the service account token. By default, it has a location, but you can also configure that token path. And it automatically goes and does some of those things for you. It logs in. It gives you a token for the role you want. And then it writes that token to a spot on disk that you've already that you've specified in the configuration. Now, I say on disk. It writes it to a volume that you've configured. In this case, you would want to configure it to write to like a tempfs drive or something. Something that's kept in memory but not actually written down in state. Granted, the tokens are short-lived. Still don't need to write things down. It actually gets persisted to disk unless you absolutely have to. And the next thing it does, maybe the biggest thing it does for you, is it manages the token lifecycle. I mentioned earlier, tokens are like secrets. They have leases. If you go and you get a token and you don't renew it, all of your access to your secrets will be gone when the token expires. So the idea here is to run Vault Agent in something like a Sidecar, automatically authenticate, and write this token to file for you. And then Vault Agent will continuously monitor the token lifecycle and will renew the token as needed. And if it hits the point where it can no longer renew, it'll automatically re-log in and give you a new token. So we'll always keep that token viable unless your credentials have been revoked or something. So here's a sample HCL. This is the way you would configure Vault Agent, right? It's not Vault itself. It's just a client mode. Vault still has to be running somewhere else. That's a separate problem that I haven't talked about yet. And I say AutoAuth, method, Kubernetes, mount path, Kubernetes. This probably had demo written in it earlier. I think if the path is just matching up with the method, you don't need the mount name. And then config, I say the role is web server. You can also give it a token path if you've used something like projected tokens, which is a somewhat new feature in Kubernetes, I believe. I get confused with Kubernetes because the new things come out, but then the major platforms don't support them right away. So, using Vault Agent to automatically authenticate with Kubernetes. It takes care of a lot of that grunt work for you. You don't have to have code anymore that knows to read the service account token. You don't have to reach out to Vault to log in, and then you still have to ask Vault for tokens. But we've cut 2 of the 4 steps out here, right? So we're trying to make things easy for you. So those are 2, or that's one quick time-wise. Okay, I am actually kind of running out of time for what I want to do. So to review, that was very, very simple, high-level, really, really easy way of integrating with Kubernetes. The kind of entry-level integration, if you will. It gets you access to Vault and all of the services it provides. And all you need is your service account token to do it. And it's scoped to the permissions and secrets you should have available to you. So this part's even quicker, actually. Vault as a service in Kubernetes. I don't know if you want to call this an integration, but I do. Let's see. Bad speaker notes. All right, historically, Vault in Kubernetes. At HashiCorp, both Vault and Consul have kind of taken a stance of maybe running in Kubernetes isn't a great idea to do that. Specifically with Vault, we have a security critical application. Kubernetes is a very dynamic environment. And although we have external backends for your database storage, it was always just kind of like, we don't want to say you can't. But we generally didn't really recommend it. We generally recommended run Vault on either dedicated machines or virtual machines. We understand the performance and reliability of those things much better than a dynamic environment. Plus, you can run Vault directly there as opposed to having to put Vault in a Docker container. So it just introduces some new things that kind of made us, we were, not against it, but yes, you can, but it didn't really fit in some areas. Plus, up until about a year ago, Vault has this concept of coming up sealed, and you need to use the keys that were created during its initialization to unseal it. Well, in a dynamic environment, every time a new Vault server would come up, it comes up sealed. Now you can imagine running a Vault cluster in Kubernetes, and there's a node failure or something gets preempted, something happens, and something gets rescheduled. Well, if all or some or maybe just the leader Vault server comes up sealed, your infrastructure is kind of hosed if you rely on Vault, right? And up until about a year ago, you needed to get in there and unseal it manually. Well, we open sourced auto unseal, so that was kind of like the last barrier of like, well, why can't we really do this? And again, I mentioned like a security sensitive product. In retrospect, security is a spectrum. So what we always felt maybe wasn't safe to do might be totally fine to you. It's up to every organization to determine what they feel is safe. So us using, well, we don't think it's a safe way to do things is not really a great excuse for not doing it, because that's up to you all to decide, right? And it turns out Kubernetes is everywhere. It turns out people were running Vault in Kubernetes anyway. So now we're looking today at first-class support of running Vault in Kubernetes, generally with the auto unseal feature turned on. And we want to enable that using Helm. Helm is a industry standard of running and generating templates for Kubernetes. It was widely supported and adopted, so we want to make sure that works. So just recently, a colleague of mine pushed the Helm chart over the finish line. And it's now available for use. It's blogged about. It's documented. We have several modes. Dev mode, that's just for experimenting, trying out. There's no persistence there. Standalone is a deployment with a persistent volume. So you can write to the disk there, and all of that data is encrypted. But it's a single server node. So you still have the problem of if it goes down, your actual entire Vault cluster is down until it gets rescheduled. And then we do have HA mode. HA mode depends on your backend, where you use to store your data. Those are all configurable, but not all of the backends support HA mode, right? We, at HashiCorp, we generally recommend you use console for HA. So if you're running console, Vault in Kubernetes can actually run really great. And we also have a Helm chart for running console in Kubernetes. So you can actually do both of these things now. Yeah, so some other features about the Helm chart, though, is by default, we can help you set up end-to-end TLS to make sure all of your connection is secure. We have anti-affinity rules in there to make sure you don't have two Vault nodes on the, or Vault pods on the same node. And you need to leverage a platform's KMS, or key management system, to provide auto unseal. And our Helm chart will help you get set up with all of those. Okay, I'm going to start kind of going faster because I wanted to get to something that I've been lagging on. So yes, Vault in Kubernetes, yes you can. An important caveat right now is that it's only open source right now. The enterprise version will come, but HashiCorp is generally a very practitioner-focused company, and so we want to nail the user experience of running Vault in Kubernetes first in the open source world, and make sure that we figure everything out that we need to before we start supporting enterprise. But enterprise support is coming. I just can't tell you when. I don't actually know. All right, so Vault as a service in Kubernetes. Let's talk about secret injection. I do not have a lot of time, but we'll talk about it. So what is secret injection, right? If we review here, this is what you had to do at first, right? You had to read the token, you had to ask Vault, you had to do these things. Then with agent, we did a lot of that for you, but we still left more, right? So what we want to do now is take all of that stuff. We want to do all of those things for you, but to date, we haven't. And a lot of people have figured out how to do it on their own. But we want to have Vault as a sidecar such that all you need to do is read something and get going. We want to reduce the amount of Vault awareness your application has. So basically, you should just be able to launch your pod and get the secrets you need. Excuse me. All right. So before I show this is very alpha. It kind of works. Well, it does work, but it works on my machine. We'll phrase it that way. I love that phrase, especially when it helps me. To set all this up, we are following Console's lead, and we're creating a separate application. Console has an application, a binary called console K8s. Yeah. We're following their lead. We're going to introduce a separate binary called Vault K8s. And you install it using our Helm chart, and it acts as, first and foremost, a mutating webhook, or an admissions hook, however you want to phrase that. It looks for pod creation that has specific annotations, and will automatically mutate your pod spec to have a Vault agent sidecar running, knowing how to configure against a certain role, and based on annotations can then automatically grab secrets for you and write them to a tempfs desk space. Why? Okay. Oh, I know. I was supposed to go to the demo then. Okay, let's see. I can't tell what you all can see. So, I can't tell what you can see. Okay, you can see my terminal. Ignore all the things. All right, I'm going to kind of go through this really quickly. I will try to show some of the things I've got. A lot of the things I'm going to run scripts, and what they are just shortcut ways of going over some of the things we've already done. So there is going to be some kind of hand-wavy magic there, but I'll try to look at the scripts first before I do, okay? So I'm using Minikube, which also kind of makes things interesting because Minikube is obviously just a single node, not a real one. So, okay. Oh, I need to do, okay. So setup is, I wasn't supposed to show this. Setup is just, we're configuring our Minikube setup to have the right certificates in Vault, and Minikube can talk securely. All right. No, okay. I don't know how to use my own terminal. All right. In Helm, I want to do Helm. install name vault. So this is using our Helm chart, but it's a private branch of it at the moment because it has this mutating webhook stuff that's very alpha. So, all right. That was easy, right? Get pods. Okay, so we can see our Vault service is running. We've actually launched Vault on Kubernetes. We're going to run Vault here. And then we have the injector pod, right? That's what we're going to do. Well, this is one of those things that I should have done before I started. Have I skipped a step? I did skip a step. This explains a lot and embarrasses me much. Cube, Cuddle, oh man, I don't know. I call it kubectl, but a lot of people call it Cuddle. No. So this is what I needed to run. So this is the part where we actually set up the Kubernetes auth provider. These are all covered in the slides I went over, except for, oh man, this thing says please wrap up. I gotta go. Okay, so we're gonna do this. No. Yep. That. Okay, great. That's awesome. Well, why not? Okay, well, my time is over and I have completely failed my demo. Which is really, really disappointing because, all right, the things flash up there and then I log in to the pod and I cat, or I use less because an old mentor of mine insists I use less and not cat, and it shows dynamic secrets were generated to disk. My colleague Jason, who worked very hard to push the Helm chart over the end, he helped with this demo and he did amazing work, and I swear it worked 20 minutes before I came on stage, and now I screwed it up. So Jason, you're going to watch this. I am so sorry. If you want to see the demo, you can find me in the hall where it will work. Yeah, so I'm supposed to wrap up, but I felt really witty. So anyway, alpha software. See, I didn't even call it beta. Oh yeah, I wanted to talk about the future. I'm over time. We need your feedback. Automatic injection is coming. We're working on it. That's probably the next 3 to 4 months horizon, right? Beyond that, we put out a blog post and we have GitHub issues. And we want to know the community's feedback here. Two things we're really considering is some kind of syncer process, obviously installed just like the mutating webhook, that will sync, automatically select secrets from Vault directly into Kubernetes secrets. Not actually like a sidecar, you can actually access it from the kube secrets way. That is pretty hand-wavy magic right now. We don't really know what that entails or what people want there. So we have 2 GitHub issues. That, and then if you saw the wonderful presentation this morning with Rita and Lachlan, container storage interface, CSI. They have a great provider framework for that. Mishra, my colleague, has already done a great demo for that. And it's in a prototype stage, but again, we want to know what does the community want out of that? How would they expect it to work? How would they interact with it? So we have GitHub issues. I can point you to them directly later on all of these things. Go there, give me your feedback, your feedback. And then you can find the driver itself at DACE Labs. They were acquired by Microsoft. So yeah, the future. We have talked about the future. There's no recap for the future because that doesn't make any sense at all, right? So I'm Clint, and I'm very thankful you all came and watched me embarrass myself with a terrible demo. All right. Thanks, everybody.